Hey everybody, Mr. Field here, and today we're going to be talking about how to find arc length. So, just a quick reminder, the other day you should have been talking about this thing called circumference. Right? And there's two formulas we can use to find the circumference, which is really just the distance around the circle. Imagine that you took this circle and maybe cut it right here, and then you stretched it out from end to end. That distance would be considered the circumference, of the circle. So there's two formulas we can use. We can say circumference equals 2 pi r, where r represents the radius, or we could say circumference equals pi d. Now, why is this important? Well, arc length is really just a portion of the circumference. It's a fractional portion, in fact. So essentially, if we can find the circumference, then we can find the arc length, or the portion of that whole circumference that we're looking for. So arc length is a fractional portion of the circle's circumference. It's like saying, hey, imagine this circle here up top is a pizza, and I just want to eat a portion of the crust, maybe from here to here. So what we can do is take the whole circumference and multiply it by that fractional portion. So, that being said, let's check it out. So the arc length formula itself, if you notice, this right here, the 2 pi r portion, that's just the circumference formula. So if we take 2 times pi times r, that would give us the circumference of the whole circle. This portion here is the new part. If we can figure out what fraction of the circle we want, we can just multiply it by the circumference, and that will give us the arc length. So let's check out a couple of examples. So we have circle P, there's the center, and it says we have the measure of angle APC, so A to P to C, this central angle here, is 120 degrees. So it's almost like, imagine we wanted 2 slices of pizza, right, out of the pie. We don't want the whole portion, we just want the whole circumference, right? We just want this piece of crust right there. That's what we're looking for. So essentially all we have to do is plug in what we know into the circumference formula. So up here we know theta, that's our central angle in this case, is 120 degrees out of 360. We don't want 360 out of 360, we just want 120 out of 360. Times 2 times pi, which we can leave as pi, or sometimes you'll be asked to change to 3.14. But in this case, we want to have exact answers, so we'll leave it as pi. And then we're going to times by the radius, which looks like is 4. So giving us right there. So times 4. A little bit of simplifying here. Well, the circumference is going to end up being 8 pi. Because 4 times 2 is 8, and then we leave that pi as is. Again, a lot of the directions are going to say leave it in an exact form. So that means just leave the pi as it is instead of changing it to 3.14 and timesing it by 8. Now, 120 over 360, we can reduce that. That's 12 over 36, because I know 10 goes into both. And I can actually reduce that even further. I know 12 goes into 12 once and 36 3 times. So basically, long story short, we want 1/3 of the circumference. We don't want the whole thing. We just want 1/3 of the trip around the circle. So in exact form, you would take 1/3 and times it by 8 pi. So just a little bit of old school math here, right? Since 1/3 is expressed as a fraction, I can express 8 pi as a fraction by putting it over 1. And I multiply the numerators, again, 8 pi. On the bottom, I get 3. So the arc length, in this case, is 8 pi over 3. This would be what's considered the exact answer. Now, if you wanted to get the approximate answer, which most of the time you won't be doing, but I just want to show you in this example, we would just take 8, times it by pi, the pi button, or you can use 3.14, and then divide the whole thing by 3, because we wanted 1/3 of the circle. So actually, let me show you one thing. If I did 8 times 3.14, that would be the distance around the entire circle, the full circumference. But notice when I divide it by 3, that gives me 1/3 of it. Rounding rules here, it would be approximately 8.4 if we were rounding to the first decimal place. All right, so there's our first example. So we can call it approximately 8.4. I don't think it gives us a unit, so we don't really have to worry about it. So that's our first example. Let's try one more. So in this case, they're giving us the central angle of 50. We're looking for this arc length here if this circle named A has a radius of 10 centimeters. So let's plug it in. We know the formula is going to be theta out of 360 times 2 pi r. So I'm thinking we're going to have theta, which is 50 degrees out of 360 degrees, equals 2 times pi times 10, which ends up being 20 pi. Sorry, it's a bad 10 there. All right, better. I can reduce 50 and 360, and a 10 goes into both. So I have 5 out of 36 times 20 pi. Now, we're going to reduce that, but before I do, just to give you a handle on things, like what is 5 out of 36? Well, 6 out of 36 would be 1/6 of the circle, or 1/6 of the circumference, 1/6 of the distance around. So 5 out of 36 should be a little bit less than that. But let's just convert it to a decimal real quick so you can see exactly like what percent we're really looking for. So we're looking for about 13–14% of the circle, 0.138. Or 0.14 if you were going to round up. But in our case, we're simply going to reduce. I know I can actually reduce, because eventually 5 times 20 is going to be 100, but I'm going to think ahead a little bit. I know I can reduce this because I know 20 and 36. I know 4 goes into both, so 4 goes into 20 5 times, and I believe 4 goes into 36. Oh, does it? 9 times. Yeah. So we're going to end up with this. So 5 times 5 would be 25 pi. Keep in mind, you could put this over 1 if you want to, over 9. And that would be our exact answer for the circumference of the circle. Again, if we wanted to, we could convert it to decimal. But most of the time, it's going to ask you to leave it just like that. All right. So those first two examples, I would say, are like the straightforward version, where they're giving you the central angle, they're giving you the radius, and you simply have to plug it into the arc length formula to find that fractional portion of this whole circumference that you're looking for. Well, in these next couple questions, they're kind of like little puzzles. You know, in math, we love to make you do it one way and make you work backwards. Well, that's exactly what we're about to do. So it says, given the arc length, they're telling us the answer. So the arc length formula is this. Arc length equals theta over 360 times 2 pi r. Well, they're straight up telling us the answer. So instead of us finding the answer like we did in the last problem, they're giving us the answer is 20 pi. Go ahead and plug that right in. The central angle is 50 degrees. So again, it's going to be 50 out of 360 times 2 pi. I'm actually going to leave r as a different color because notice now we're finding the radius. It wants us to work backwards. So it's kind of like a puzzle. We're plugging in the answer, and then we have to get r all by itself. So there's several ways to do this. Since we just did this problem earlier, we know 50 out of 360 is going to end up being, in this case, we simplify 5 out of 36. So we can do that again. We really have 5 out of 36 times 2 pi r. Now, one more thing before I actually do that, let me head back a little bit. We can realize that multiplying by 2 pi r, well, the opposite would be to divide by 2 pi. Canceling the 2's, canceling the pi's out. We would also cancel these pi's out. Remember, whatever you do one side or the other. And we end up with this. 14, it's half of 28 is 14, equals 50 over 360 times r, which is eventually going to be this when we simplify it. 14 equals, well, 50 over 360, pardon, is 5 over 36. And then times r would really just give us, or yield us that, 5r over 36. Now with a little algebra here, we can either do this, if you're feeling a little more advanced, we can multiply by 36 over 5, the reciprocal, and kind of kill 2 birds with 1 stone, make 2 moves at once. Or if you're uncomfortable with that, we realize, hey, what's happening in the r? Well, right now it's being divided by 36. The opposite would be to multiply by 36. Cancel. So we'll do 36 times 14. Let's see what that is. Our handy dandy calculator. 504 equals, well, 5r. And then you'd ask yourself, well, r is not by itself yet, I don't think, right? So we have to divide by 5. And I believe that should be our answer. So a little over 100 for our radius. Add inches, because I'm being silly here, right? If it has a unit, we better include it. Since it told us that it was 28 pi inches, it's giving us that unit in the beginning of the problem, we should make sure that we actually include that in our answer. So I'm actually going to skip 2b because it's very, very similar. I want to try something different. Let's go down to like example 3a. So again, they're going to be asking us to work backwards. It's not like your normal straightforward problem where you just plug the numbers into the formula and it spits out the arc length. So let's start with the arc length formula. We know it's theta over 360 times 2 pi r. Well, in this case, it's giving us the answer. The arc length is 4 pi. So we can go ahead and plug that in right here on the left side of the equation. Notice it says find the measure of angle QOP, that central angle there. We don't know what it is. We do know the radius. So this is one of those little working backwards or puzzle-like problems. So we're plugging in the answer, and we're going to work backwards to get, in this case, not r by itself like the last example, but we're going to work to get theta by itself, that angle. So we know 4 pi is going to equal theta over 360. And sometimes you might even see teachers use m over 360, like as in the measure of the angle. So if you're more comfortable using m, you can do that too. But I'm going to leave it as theta because theta is just another variable, times 2 pi, and then r in this case was 9. So we can go ahead and simplify 2 pi times 9. That's really 18 pi because 9 times 2 is 18. And my first move is going to be to realize, hey, this is multiplying by pi over, or sorry, 18 pi. The opposite would be to divide. So over here, everything's going to cancel, the 18s and the pi's. And whatever I do to one side, I better do to the other, which is going to cancel the pi's, getting rid of that variable, essentially. And then we can simplify 4 over 18. I'm thinking it's going to be 2/9. Now, you've seen problems like this before. There's really an easy way to solve this. This is a proportion. So notice we can simply cross multiply these and get our answer. So we're going to have 9 times theta equals 360 times 2. I know 36 times 2 is 72, so this should be 720. And then we ask ourselves, is theta by itself yet? No. We're going to divide both sides by 9. Well, I know 9 goes into 72 8 times, so it must go into 720 80 times. So these are going to cancel, and we're going to be left with the central angle theta is 80 degrees. Don't forget the degree symbol. You don't want to lose a point for not including degrees. So I'd like you to try example 3b on your own using 3a as a model. I hope that this video was helpful. Thanks for watching.